Good afternoon, everyone. I'm Jim Holcomb, president of the SAIA. I want to welcome you to another SAIA educational webinar. Today, we are examining our 2019 Shoring Project of the Year awarded to PCI Scaffold, Division of Performance Contracting, Inc., for their Enhanced Circulation Elevator Relocation Project for the Seattle Headquarters Project. Presenting this webinar will be Daryl King. Daryl has been working in the scaffold industry since 1990. He began his career as an erector in the field, working his way up to a foreman and on to operations, dispatch, and safety management. He has been with Performance Contracting, Inc. Scaffold Division for the past 12 years as a senior estimator, and with the PCI Seattle Scaffold Branch working as their operations manager since January 2020. Please welcome Mr. Daryl King.
Thanks, Jim, for the introduction, and thank you everybody for taking a few moments out of your morning to listen to this presentation. I'm probably a better project manager and estimator than presenter, but I'm going to give it a good try here. So, to start with, we had a good relationship with GLY Construction. They contacted us in 2017, late, to have a look at a strange shoring project, they called it, which encompassed a shear wall that's 80 feet tall. And it was the backside of an elevator that needed to be relocated for the client's requirements. And what they had indicated to us is that, the shear wall, it's a C-shaped shear wall. And what they needed to do is hold it up in place, and it couldn't move within, a 1/16 of an inch. Also, they had to cut out basically the whole bottom of it and excavate down underneath it about 15 feet and remove the footings. So the shear wall would basically just be hanging there, supported. So we had a meeting, we sat down with them, and that's when I knew quickly that this wasn't just a traditional shoring job. So we partnered in with DHC Engineering, which is our main point of contact for all engineering. And we just sat around round table at some point, just threw out ideas of what could be done. We certainly knew that it wasn't going to be held in place with a certain amount of steel, and I'm not sure how it came about, but at some point, somebody during the conversation raised the point, well, why don't we just have beams through the wall, cut some holes in the wall, and support the wall with some steel beams. So that idea actually garnered some steam, and DHC went after the meeting. We went back and started just throwing out design ideas. This was all done. We basically had told GLY, well, we really don't know what the cost will be, but we know we can do it. So they gave us an NTP for engineering and design build, and DHC went to work. It was quite the there were several iterations of shoring methods and means to get this done, but eventually DHC came up with an idea for some build for some steel to go through the walls. The steel beams were eventually eventually the design was approved, and we went to work on the plans. As you can see, the combination of the beams, the towers needed to pull this off, needed to be strong enough to support the shear wall, but also needed to be compact enough that the wall itself could span between the beams. An interesting fact is the beams that were sourced by DHC, there's only 7 beams in the AISC manual that weigh more. And these particular beams had to be sourced from outside the state and trucked in. They were so large. Project location played a factor as well, because the building was located really right at sea level. So the excavation was going to happen basically about 15 feet below sea level. So what this meant is the soil had to be frozen just so the excavation could take place, and obviously so nothing would slip. That created the factor of making sure that the excavation area and the frozen soil would not be overloaded by a surcharge, the loading of these HSS beams that were basically set down on grade, and then holes were punched through up to the first floor from the basement for these beams to basically be rested on. So after certainly countless load calculations and months of work, the design was finally approved. There's some photos of the actual beams in place. PCI didn't place the beams, but there was a steel erection company that installed these. And if you can see the picture on the top left, first picture, shows the shear wall / elevator core, basically. And you can see the beam layout down below in the plans. So you can see the 2 holes were punched in the elevator core wall, 2 foot thick shear wall. And if you can see down below, there's these very large HSS box columns that these beams are resting on, and those went all the way down to grade. So really, those are the 2 or 4 main beams that supported this wall during or were going to support the wall during the excavation. As you can see, it was 1.5 million pounds for of the total weight to be shored. After the beams were placed, then we had some additional shoring needs to reshore all the floors that connected to the shoring wall adjacent, and there were several of them. I believe 7 floors, 7 levels. I would stop right now and just ask if I've gone too fast, or if there's any questions by any of the group.
I'd also like to mention that we do have the chat option down at the bottom. So if you are not able to ask a question, or if you don't have the ability to, just go ahead and click in that chat function, and I'll be happy to relay the questions to Daryl for you.
Okay. So to account for the reshoring of all the adjacent floors that were attached to the shear wall, as you can see in these pictures, cupola scaffolding was designed to set on top of the steel beams in place and shore up the adjacent floors from level 1 all the way up to the penthouse. This ensured that all the floors were accounted for, and the roof loading, to basically make sure that the beams were really only supporting the shear wall itself, and that's it. So even with the tributary slab loading being supported and not acting on the shear wall, the 1.5 million pound load it still caused too much deflection in the beams. So if additional support was not added during the foundation cut, an estimated 1/16 of an inch wall movement was possible. So also DHC came up with a jacking plan on top of the steel beams, which was quite an interesting project. Watching after all the shoring was installed, these small pancake hydraulic jacks were installed on top of the steel beams and in between a gap that was in the wall, and so they had steel plates, and they did have a predetermined gap in between the beams and the wall, and each one of these locations was they did this target jacking to ensure that shear wall was equally loaded all the way around, and that was pretty impressive to watch too. With all the science and technology and computer work going on, they successfully preloaded the wall basically before the cut. Just to push up on the beams to ensure that the deflection limitation was limited even after the wall was cut. The amazing thing is, after all of the installation, the shoring, the jacking, the walls never did deflect more than a 1/16 of an inch. Also, the soil conditions were a lot worse than they ever imagined. Once they got down below grade, you can see in these pictures, that's still, the foundation is still in place, but it's frozen. So they dug down, took the slab out, and removed all the dirt, but they were chipping away at frozen dirt and water. So at one point, they couldn't keep up with the water coming in, so the pit completely flooded with water. So they had to freeze even additionally more than they thought, bringing in this hydro-freeze process that's been commonly used around here in Seattle, where they drill down and have tubes stuck in the ground, refrigeration tubes, and they literally freeze the ground around the excavation, which is really kind of an amazing process too, because once you get down in there, the ground is as hard as a rock, but you know, they're chipping out blue chunks of ice that, you know, are, 5 by 5 pieces of solid ice. So they had the uncommon problem of thawing, plus certainly demo of concrete, mud and water, frozen water, and dealing with all that. So as it turns out, the excavation took way longer than had planned. So the delay was, that wall sat there like that, in that condition, as you can see in these two photos, with the rebar sticking out. Now you've seen there's a clean cut. That wall had to sit there like that for almost 4 months because they couldn't excavate quick enough, and the water just kept coming in. They finally got it sorted out, got the soil freeze conditions right, that added an additional cost of about $15,000 per day for liquid nitrogen. Here are some more photos, certainly of the excavation. You can see it as it got later in the excavation, the walls became thicker with ice. You can see photos left, right, and middle. Here's the fully supported shear wall now, rebar sticking out, basically ready for the brand new foundation to go into place. So with the, you know, the extensive design phase of this project, we began in, you know, 2017, roughly fall. It took another, you know, it took several months to install the shoring systems. And it wasn't complete until May of 2018. And then, like I said, there were several delays in the project. So the shoring stayed in place until December of 2018. We were still able to stay way ahead of the project. Certainly, this was one interesting shoring project of actually 3 that we did on the building itself. And we believe that the 2 other shoring projects that we did maybe would have qualified for certainly for a project of the year as well. So DHC really had their hands full, not only with this one, but the 2 we did 2 facade shoring projects as well on this building. So in wrap, you know, to wrap, GLY it really was quite impressed with everything we did for them. And, you know, certainly the elevator turned out well. This was all done to basically rotate an elevator 90 degrees. So at this point, I think that's probably about all I have to say, but I certainly, there may be some questions, some photos, some people would like to go through. But that's about all I have at this point.
Okay. Does anybody have any questions for Daryl? Jackie, do you have any on the chat?
I do not.
Okay. Well, thanks, Daryl. That was a great presentation. If you haven't registered yet for our virtual convention to be held September 15th through the 17th, please go to the SAIA website and register today. All attendees registered before this Friday, August 28th, will receive a welcome box in the mail sponsored by B Access Products. Thanks for attending. Be safe and enjoy the rest of your day.